These last couple of months, we have been showcasing our spreadsheet-powered AI concept, and as a result, people have been interested in knowing a little bit more about how it works and what's going on behind the scenes. Now, if you haven't seen the demos, you can find links below, but in short, it allows you to drop a spreadsheet model into a ChatGPT-like conversation and then start interacting with the model, changing values, seeing the results of calculations, and even building a small data app, as you can see here on the side. In this case, we are having a conversation with a business model, asking about some of the assumptions, how they might affect the outcome, and essentially how we could reach our revenue goals according to this model. Here's another example. This is a pricing conversation. You could, for example, imagine an LLM bot on a website already answering customers' questions. Can answer all sorts of questions from the company's textual data, but with the addition of spreadsheet-powered AI, it can also confidently and reliably answer questions about pricing based on an underlying spreadsheet model of any complexity. I'm going to use this example to talk a little bit about how this works and what's going on behind the scenes. Now, the pricing model that we're using for this example is deliberately simple because it's easier to talk through it that way. But our technology can work with any model that you can build in, whether it's in Excel or Google Sheets of any complexity. In this model, it might be a pricing model for a piece of software. You have a number of seats, you have a number of sites, and then you choose whether or not to include priority support. There's a unit price attached to each of these. That calculates an intermediate price, but nobody pays less than $1,200, let's say, per month. So the first thing we do when we see a spreadsheet like that is we parse it, and we'll kind of tease out the data from the Excel file or the Google Sheet and turn it into a dependency graph. A dependency graph is at the heart of any spreadsheet engine, where you essentially turn the formulas and the two-dimensional layout of the cells into a hierarchy that is then used to calculate the outcome. So in this case, we identify the inputs, B2 to C4, we go back. It's essentially these 6 cells that are the inputs. They are the ones that drive the calculations. Then you have some calculated values, intermediate calculated values, and finally you have an output in cell D9, which makes sense. That's the final price down here. Now the next thing that happens is that we will go through all the cells that have values and are involved in the calculations, and we'll search for labels that help us understand how a human might refer to these cells. So here, for example, we have cell C3. There's no metadata on that cell, but by looking at the surrounding cells, we will identify the word sites and the phrase unit price and associate that with this cell. Similarly here, there is no metadata on cell D9, but it is probably meant to signify the final price because of the way it's located in the spreadsheet. Now, this is in addition to other things like the values, the formulas, the number formatting, and other formats of the cells. This metadata is attached to the cells in the nodes in the dependency graph. And here we have almost like a human readable dependency graph where the number of seats and the unit price per seats calculates the total price per seats, which feeds into the intermediate price, which feeds into the final price, and so on. It's very easy to kind of read through the logic in the spreadsheet based on a dependency graph like this. Now, the second thing we do is that we have exposed certain functions of our spreadsheet engine to an LLM. So essentially, we list them, and here we have calculation functions such as reading values from certain cells, running a formula, creating a scenario, which essentially means setting values of one or more cells and run a calculation. We have goal seek, we have reset, and a few other things. And then we have also elements. So we are able to show the contents of the sheet, create elements, whether they are kind of, they could be sliders, they could be charts, and so on. And there are various different ways of doing that. This is all packaged up in a prompt. So the semantic spreadsheet metadata, the API functions we want to expose, and the instructions and directives that are fairly standard, as you can imagine for such a bot. And this then gets fed into any LLM. The demos that you will find in the videos are running off of OpenAI. We have done an integration with Anthropic's Claude, and this also works on top of Llama from Meta. So essentially, it doesn't really matter. The LLM doesn't matter all that much. We are using the same or more or less the same approach regardless. Now, if we take a look at interaction time. So all of this happened at initiation time, but what happens at interaction time? In one of the demos, you will find this question: what would the ad budget per month need to be to reach a certain number in ARR? Now, it becomes very natural to ask that type of question when you have a conversation with a spreadsheet, but it is not necessarily a straightforward calculation in a spreadsheet unless you know about the goal seek function, which not all spreadsheet users do. Here it's a natural conversation. You ask a question, you get back an answer. What's happened? How do we get there? Now, in short, when we feed the question, what would the ad budget per month need to be to reach 1.2 million in ARR, into OpenAI's Assistant API or one of the other LLMs. And based on the context that we have given it, because we've given it the metadata, we've given it the functions that are available to it, or the tools, it decides that it will do a function call for the goal seek function with the parameters target cell. That is the in that model, that is where the ARR resides, the target value of 1.2 million, and the input cell of B4, that's where the ad budget is. This is then sent. This gets turned into a tool call to our spreadsheet engine that runs the goal seek and returns the result, which OpenAI packages back into natural language and gives back to the user. Now, the interesting thing here is that the LLM is really the commoditized part. As I mentioned before, we are using multiple LLMs for this, but there aren't any spreadsheet engines that can run headless like what we are doing in this demo. That can allow you to take a spreadsheet model out of Excel or Google Sheets where they are built and run them as a web service or as a client-side service in the browser, both of which is something that our engine can do. So at the heart of this is our spreadsheet engine, and it's very hard to enable any of this without something like that. We talk a little bit about the engine. It's actually an engine that we built from scratch and has been running behind web calculators for a few years. It's the most sophisticated independent spreadsheet engine in the world. With that, we mean a spreadsheet engine that lives outside of Microsoft or Google, and we say that with a lot of confidence. It is very compatible with both Excel and Google Sheets. Even where they differ, we will be able to chase either mode, either the Excel mode or the Google Sheets mode. It's already powering thousands of web calculators out there where our performance is optimized for animation, because a typical interaction there is moving a slider that affects calculation and then running in real time in animation speed the results of those calculations to update charts and other visualizations. It has deeply integrated visualization and interaction layer to enable all of that. So a slider will immediately and directly affect a calculation, and that in turn immediately update any derived values and the visualizations of that. And like I mentioned before, it can run in the browser and in the cloud alike. So you can either have client-side calculations where the entire model in the engine is running in your browser. That's written in JavaScript and partly in WebAssembly. And it can also run as a RESTful service in the cloud, allowing for all sorts of LLM projects that you can integrate, either through a JavaScript on the client side or through a RESTful call to the cloud service. So we hope that this will actually be enabling all sorts of calculations in LLM projects all over the world. If you want to know more, please go to Spreadsheet Powered AI and reach out to us through there. And we've been happy to have conversation about how we can enable spreadsheets and spreadsheet models and calculations in your LLM projects. Thank you.